Hey there. Today we are talking about section 6.1, estimating with finite sums. So what we're going to be doing is we will find distance traveled, um, or otherwise known as area under the curve, rectangular approximation method. So finding the area, the approximate area using rectangles, and the volume of a sphere. Cardiac output is going to be one of the um, exploratory things that we will do. Example, finding distance traveled when velocity varies. So I'm just going to run through this because they have this whole thing completed, and then we will do one. So a particle starts at x equals 0, moves along the x-axis with a velocity v of t equals t squared for time t is greater than or equal to 1. Where is the particle at t equals 3? So graph the velocity function and partition the time interval into sub-intervals of length delta t. So some value that splits it evenly. If you use delta t equal to 1/4, you'll have 12 sub-intervals. The area of each rectangle approximates the distance traveled over the sub-interval. Adding all of the areas or the distances gives an approximation to the total area under the curve, or the total distance traveled from 0 to 3. So it looks like this. Here is your function. They're going to break it into 12 different sub-intervals of width of 1/4. So they just did up to 1 on this table. But basically what they found was, what is the midpoint between 0 and 1/4? We got 1/8. They put 1/8 into the function. That's how they get this here. Put it into the function. So we have a width of 1/4, a height of 1/64. So that first rectangle has an area of 1/256. So that what we're talking about is this little tiny area, that rectangle way down there. Second one, halfway between 1/4 and 1/2 is 3/8. The height of that, so we take 3/8 and put it into the original function, the velocity function, you get 9/64. So you take the width, which is 1/4, times the height, which is the area of a rectangle, multiply those, I get this, and so on and so forth. So they end up with all of this, which is roughly 9.8 when they add everything together. So when we are doing these kinds of problems, it's called rectangular approximation method, RAM. You will have a RAM program on your calculator. We will use it, but there are a lot of times that we do not need our calculator, and or we don't have, we have a non-calculator quiz. So we need to do it by hand. Left RAM means when you're looking at the interval, you will use the left side height for the height of the rectangle, and then the width is going to still be the whatever the width of that rectangle is. Okay, so on this one, this is going to be LRAM. The height of that first rectangle is at 0. And then we have the width here. It looks like 1, 2, 3, 4, 5, 6. Looks like the width is all 1/2 here. And then the next one is going to be MRAM. So going on each interval, we find the midpoint between each interval. And we're using that as the height of the rectangle. Our width is still whatever the width was to be determined. The final one is your right RAM, and that means for whatever interval you are looking at, the right side determines the height of the rectangle. So look at the rectangle, look at the right side. How high is it on the right side? That's going to be the height. And then, of course, you should know the width. I think we said the width was 1/2 on these rectangles up here. So here is one that we are going to work through. So find the area under the curve y equals square root of x from x is 0 to x equals 4 using 4 equal rectangles without a calculator. And we can use the RAM method of your choosing. Also, I'm going to kind of work through all three of them. So what I did was I made a table of values to help with finding the height of the function. Okay, so we are doing 4 equal rectangles here. I need a pen. Boom. So 4 equal rectangles. So we can use left ram or right ram. And really, I would only need values at 0, 1, 2, 3, and 4. But if we're using M ram, the midpoint, I would actually need more values. So I did the half values as well, just simply because I didn't know which values we were going to use. So we are going, here is your square root function. We are going from 0 to 4. We're finding total area underneath there. So if we were using LRAM, so I'm going to go through this real quick, sorry. The width of each rectangle is 1 unit, right? From 0 to 1, 1 to 2, 2 to 3, and 3 to 4. The height is determined by whether we're using the left side, the right side, or the midpoint of the rectangle, and that value is then substituted into the function. That's the height. The area of the rectangle, of course, is length times width. So we have the width of the first rectangle is 1. The height here is on the left side. So we have this, here, I'll put this in there. This is your first rectangle, right? From 0 to 1, right here. Okay, the left side is 0. It's 0 high. So this guy is going to be 0. The next rectangle, the left side is 1. The next rectangle, the left side is square root of 2. And then the next rectangle is square root of 3. Because all of these rectangles have the same width, we can pull that 1 out. That might make it easier for you to solve, and then simply add first and then multiply by that common width. So I have 1 plus square root of 2 plus square root of 3. Not much to simplify on that one. If we are doing the right side, I'm going to simply do the same thing. My width is still the same, but now I'm looking at the right side of the rectangle. So for this first rectangle, which is here to here, my right side height is 1. My right side height for the second one is square root of 2. The right side height for the third one is square root of 3. And the right side height for the fourth one is positive 2. So the answer here was 1 plus, I'm just going to leave this. Answer here is going to be 3 plus. Notice that this one is 2 higher because it's going to over approximate. Our MRAM, so we're looking at the same intervals, the same rectangles, but we're looking at the middle value. So on the first one, it's square root of 2. Second one is square root of 6 over 2. I did simplify those when I wrote them down. Square root of 6 over 2, square root of 10 over 2, and square root of 14 over 2. Super fun. So there we go. Okay, that will approximate the area from 0 to 4 on the square root of x. If the velocity of an object is given by the function v of t equals sine of t, we're finding the total distance the object travels from 0, or t equals 0 to t equals 3/2. We're using a RAM method of your choosing, using 6 equal rectangles without using a calculator. So I went through again and I made a table of values here. And it is a sine function. So your sine function at 0 does start at 0, it hits its maximum, it goes back to 0, goes to its minimum, etc. We're only going to go to the minimum. But when we are finding total distance traveled, because part of it, so it starts at a value, goes down and comes back up, is basically we're going from here to there. So this will be a positive value and this will be a negative value, but we want total distance. So let's say you leave the house and you're traveling forward, whatever, you're traveling forward, and then you forget something and then you go back. We're still finding how far did we travel. So we're actually going to make both of these positive values when we do that. So right ram, left ram, mid ram. I didn't do the mid, so I'm just going to either use right or left because I didn't do the mid values in here, just simply because I want to do the sine of pi over 8 and end up with those half angle formulas. I don't want to do that. So let's do left ram. So on left ram, here we go. Okay, our width of each is still going to be pi over 4. So I'm leaving that. So the left ram on the first one is 0. Right, here is the first rectangle. The left side is 0. The next one, left side is square root of 2 over 2. The next one, let's go down a little bit, is going to be 1. And then we have square root of 2 over 2. Here's a little kicker because we are adding. We want to figure out where we are at. Our left one here is 0. Finally, our last left side here is negative square root of 2 over 2. But because we want to make it a positive value, we want to know how far total did we travel. We're just going to make it that a positive. So I should have pi. I hate when I click that button. Go away button. All right. So pi over 4. And then we have 3 square root of 2. Square root of 2 over 2 plus 1. I can probably combine those. I'm just going to leave it as is. Right ram is going to be very similar, but again, we are using the right side. So instead of 0 for my first one, I'm using square root of 2 over 2. I'm hoping that you notice that almost all of them are the same, except instead of using this guy, we're using that last one. Again, we're making it a positive. So when I add these together, what do I get? 1, 2, 3 square root of 2 over 2 plus 2. Here we go. So this guy is 1 more larger. Right ram is a little overestimate. I don't know if this one's an underestimate, potentially. Okay, so that is it for this section.